Hello, my name is Xinrui Chen and my net ID is XCH56. This is the question 1 for homework 6. Firstly, for the random variable x and y have the joint density function, which is the joint density function of xy equals to 1 plus xy over a when absolute value of x and y both smaller than 1, and the joint density function equals to 0 when in other conditions. Firstly, we need to find a so that the above defined is a valid joint density function. So the double integral from -1 to 1 of 1 plus xy over a dx dy should equals to 1, and we can calculate this equation as 4 over a, which is equals to 1, so that we can get a equals to 4. For question 2 and 3, we need to prove whether the random variable x and y are uncorrelated and whether they are independent. Firstly, we can calculate the expected value of the product of x and y, which is equals to the double integral from -1 to 1 of xy times 1 plus xy over 4 dx dy. And after calculating, we can find that the expected value of the product of x and y is equal to 1/9, and we can calculate the expected value of x, which is equals to the double integral from -1 to 1, both from -1 to 1 of x times 1 plus xy over 4 dx dy, this equation, and we can calculate that this value equals to 0, so that we can find that the expected value of the product of xy is not equals to the expected value of x times expected value of y, so that the x and y are not uncorrelated and not independent. For the question 4 and 5, we need to find the joint density function of x squared and y squared and prove or disprove that the x squared and y squared are independent. Firstly, we can let z equals to x squared, w equals to y squared, and the Jacobian is equals to 4xy, so that this function has 4 roots. When z is larger and equals to 0 and smaller and equals to 1, w is larger and equals to 0, smaller and equals to 1, the Jacobian I, absolute value of Jacobian I is equal to 4 times four times the square root of z times square root of w, where I equals to 1, 2, 3, 4, and the density function of z and y should equals to this equation. And after the calculating like this equation, we can find that the joint density function of z and w should equals to 1 over 2 times square root of z times 1 over 2 times square root of w, which is under this situation. When z is smaller than 0 or z is larger than 1 and w smaller than 0 or w larger than 1, the joint density function of z and w is equals to 0, so that we can find the joint function joint density function of x squared and y squared. And we can find that the joint function of z is equals to 1 over 2 times square root of z, and the density function of w is equals to 1 over 2 times square root of w, and so that the joint density function of z and w should equals to the density function of z times the density function of w, where this proves that the x squared and y squared are independent.